Dear students, today we shall take up on the topic glaciers. In Unit 2, Walks of Glaciers, you will come across in Unit 2 and we shall be taking up these walks of glaciers. First, what are glaciers? Glaciers are rivers of ice, or we can say glaciers are moving ice. Snowfields are the parents of the glaciers. Large mass of ice moves down the slope as the river flows from high levels to lower levels. Thus, a glacier is a large mass of moving ice. It is tongue-safe. Glacier is tongue-safe, and the end of the glacier we call it snout. Let us look into the movement of the glacier. What are the factors that cause the movement? Roman number one is pressure of the ice, slope of the land, then the pull of gravity. Looking into now the types of glaciers. According to location, size and length, the glaciers can be divided into two major types. Number one is valley glaciers. These glaciers rise from high mountains. These flow down the valley slopes. These are also called mountain glaciers. So valley glaciers are also called mountain glaciers. These glaciers were first found in the Alps mountain, in the Alps. So these are also called alpine glaciers. They've got different name. Some glaciers are of many kilometers long. The largest of the Indian glaciers is Cirque, which is 72 km long. This is the picture showing a valley glacier, mountain or alpine glacier. This is in Alaska, in United States of America, in Alaska. This is alpine glaciers, how the ice moved down. And these glaciers, coming to number two is continental glaciers. These are the largest of all glaciers. They cover vast areas in polar regions. These are also called ice sheet. Continental glaciers are also called ice sheets. This is a picture showing the extent of continental glaciers. Peak of Wisconsin. These are the glaciers. About 25,000 years ago, large ice sheets covered most of North America and Europe. At present, two major ice sheets still exist in Greenland and Antarctica. Greenland covers an area of 7 lakh square miles, while Antarctica covers an area of 50 lakh square miles. This is picture showing glaciers in Antarctica. The walks of glaciers, looking into how it works, how glacier works. Glacier, like other agents, plays a combined role of erosion, transportation, and deposition throughout its course. On mountain slopes and valleys, its work is mainly erosion. On plateaus, its work is mostly protective. On lowlands, its work is deposition. So it performs many functions. Coming to erosion, glacier performs erosion by different actions like plucking, grooving, abrasion, grinding, then polishing. A glacier plucks big pieces of rocks from the underlying rocks. Big hollows are formed on the valley floor. The glacier collects big pieces of rocks from avalanches and landslides. These fragments are the powerful tools of glacier. The glacier scratches polishes the rock surfaces and grinds the pebbles and stones at its bottom. In this way, mountains are becoming rounded, and valleys are deepened and widened. Valleys are deepened and widened. The general rugged highland area becomes smooth. The glacier erosion depends upon the following factors. Roman number 1 is the amount of ice. Then Roman number 2 is nature of the rock. Number 3, movement of the glaciers. Number 4 is slope of the land. Landform formed by erosions. We can see here the picture showing about the glacier. We can see here many terms related to glacier, like a col, horn, a reed, hanging valley, truncated spur, cirque, outward plain, and terminal moraine. And we can see here lateral moraine, and in the middle medial moraine. We can see here little details. Outward plain is Cirque drumlin, then here outward is Cirque drumlin, then terminal moraine, then outward plain, and Cirque. Coming to some important terms about glacier. Number 1 is cirque. Cirques are semicircular hollows at the side of a mountain. The moving ice produces depressions on the slopes of the mountain. This are the picture. These are like armchair depressions, like an armchair. Here we can see here. These are like an armchair, and we call it cirque. Plucking and frost wedging deepens and widens these depressions. What make this cirque? We can know that plucking and frost wedging. It deepens and widens this depression. An armchair safe basin with a back wall is formed. An armchair safe. It's like an armchair safe basin with a back wall is formed. These are known as cirques in France. Corries in Scotland. It has got different names. Cirques in France, corries in Scotland, CWMS in Wales, and cairns in Germany. After the melting of ice, a turn-like is formed in these cirques. See, this is like a turn-like armchair depression. These mountains covered by ice. We can see here turn. This armchair depression cirque, and let's turn into turn. We can see here the picture turn. Turns a small mountain lake, especially one that collects in a cirque basin behind rises of rock material or in an ice gorge. We can see here the picture. This is a turns. Mountain lake especially collected in cirque basin in armchair-like depression. We call it these turns. Let us just know it in a very simple way. Turns means a small mountain lakes in the glaciated mountains. Coming to the second term, another term, horns. Sometimes several cirques are formed on all sides of a mountain. These cirques cut back together until these almost meet. The horn is a classical feature of alpine glacier. We are looking into horn. This is what we call it, horn, glacier horn. And this is the horn, this picture, this peak, the top, the summit, this part we call it horn. A horn-shaped pyramid is formed. This sharp-pointed peak is known as horn. The Matterhorn of Switzerland is a classic example. And coming to another term, col, C-O-L, col. Col is a saddle-safe pass through mountains. It's a saddle-safe pass through mountains. When on the opposite sides of ridges, two cirques meet, a call is formed. How is called formed? We can see here that when on the opposite side of ridge, two cirques meet. When two cirques meet at the opposite side of a ridge, a call is formed. So we can see the picture here. How this call, this peak, horn, then armchair-like depressions. We see here cirque. Call is a saddle-like narrow depression formed by two headward eroding cirques that reduce and aerate. We can see here the picture. You can identify it. For U-shaped valley, another term, U-shaped valley, when a glacier enters a V-shaped valley, it changes its shape. The glacier widens and deepens the valley. See, earlier it may be a V-shape, but later on, with the passage of times, it turns into U. V turns into U and become a U-shaped valley. These are U-shaped valley. A V-shaped valley thus becomes a U-shaped valley. It's because of erosion. Glacier eroded those rock materials and the V-shape at last turns into U-shaped valley. A U-shaped valley has wide flat floor and steep sides. Wide flat floor and steep sides. It will have a steep side. St. Lawrence Valley of North America is a U-shaped valley. Drawn glaciated valleys are known as fjords, as along the coast of Norway. Drawn glaciated valleys, which are drawn under water, we call it fjords, along the coast of Norway. See, we can see here, which are drawn, the submerged part of the glacier. This part we can see here. And coming to another term in the glaciated regions, hanging valley. A hanging valley is formed by a tributary glacier. The main glacier forms a much deeper valley than a tributary glacier. After the ice has melted, the tributary valley is left at a higher level than the main valley. Such valleys appear hanging above the main valley and are called hanging valleys. They appear like hanging, so we call it hanging valley. When valleys are left at a higher level than the main valley, let us not forget. It looks like hanging. See, these valleys looks like the hanging, so we call them as a hanging valley, like this. You can see the picture here, the diagram here. These are U-shaped valley or V-shaped valley, but it looks like hanging, so we call it from this level hanging valley. Rivers perform transportation, another word, transportation. Here glacier carries different types of materials, different types of load, like a river. These materials comes from avalanches. We know what is avalanches. Great height, valley floor and walls. The glacier transport boulders, clay, till, drift, gravel, sand, etc. How glacier perform this transportation and what are the materials transported by glacier. These materials are transported in different ways. Roman number 1, how they are transported. Drag it under the bottom of the glacier. They are dragged under the bottom. Roman number 2, carried on the surface of the glacier. They are carried transported on the surface of the glacier. Then number 3, collected in the layers of the ice. They are collected in the layer of the ice. That's about transportation, and now we are coming to deposition. Glacier also performs depositional works like river. When a glacier melts, it is called the retreat of a glacier. Most of the material brought by a glacier is deposited. These deposits are called till or drift. Most of the material brought by glacier is deposited, and the deposits are called till or drift. Glacier deposits its material in the form of hillocks. These are known as moraines. Now, what are moraines? Glacier deposit material in the form of hillocks. We call it moraines. According to the place of deposition, moraines are of the following 4 types. So now let us look into the 4 types of moraines. Depositional landform created by alpine glaciation. Looking into this picture, this glacier drift, a general term of glacier deposits, both sorted and unsorted drift. Stratified drift are those sediments deposited by glacier, meltwater that are sorted by size. Tills are unstratified and unsorted debris from ice deposits. Moraines, then valley train deposit. Let us look into moraines, the 4 types of moraines. Lateral moraines, a deposition of sediments along both sides of the glacier. If moraines are deposited at both sides of the glacier, then we call it lateral moraine. Then medial moraine is a deposition of sediments between 2 lateral moraines. If the deposition is between 2 lateral moraines, we call it medial moraine. Then terminal moraine, eroded debris that is dropped at the glacier farthest extent. We call it terminal moraine. Here we can see here, this picture here. These are the deposited materials. These are the moraines. And since this is in the middle, we say medial moraine. Then at the side, at both sides of the glacier, here at the right side, here at the left side, we call it lateral moraine. Then where it ends, where deposition ends, we call it here this terminal moraine. Lateral moraine, and then in the middle is medial moraine. Coming to lateral moraines, once again, the material deposited on the 2 sides of the glacier is called a lateral, or we can also call it marginal moraines. Then it is a ridge of loose and broken materials rising to a height of 100 feet. Number 2, medial moraines. These are formed by the meeting of 2 glaciers. When 2 glaciers meet, they form medial moraine. When 2 glaciers meet at a point, the inner lateral moraines unite to form only one ridge. This ridge along the middle of the main glacier is called a medial moraine. Number 3 is terminal moraine. When the glacier melts, some materials is left behind at the snout of the glacier. This is called end moraine or terminal moraine. It's better we memorize end moraine. Where the moraine ends, we call it end moraine. Number 4, coming to number 4, types of moraine. Ground moraines. The material deposited underneath a glacier is called a ground moraine. These are found scattered on valley floor. Let us see this picture. This ground moraine, then end moraine, then drift outwards, then meltwater. We can see ice front, ablation area. Then this is at the side of the glacier, this moraines, lateral moraine. Then sediments from erosion of valley walls incorporated into surface of ice. Then these are the accumulation area, ice accumulation area. Then these are the crevasses. Then here we can see Block eroded from valley floor incorporated into sides and beds of ice. Coming to other landforms, number 5, other landforms. After the melting of the glacier, many streams flow from the end of the glacier. These streams deposit sand and gravel in different layers to form an outward plain. Kettle lakes are formed by filling of depression with water. What are kettle lakes? We can see how they are formed here. Formed by filling of depression holes with water. We can see here this very clear pictures about kettle lakes. Kettle lakes. It is formed when an isolated block of ice persists in a ground moraine. An outward plain or valley floor. After a glacier retreats, as the block finally melts, it leaves behind a steep side hole that frequently fills with water. Oval-shaped deposits like an inverted boats are formed and are known as drumlins. These are drumlins. We can see here like oversized boats. We call it this drumlin. These deposits appear like eggs in a basket. Long narrow ridges called iskers and small rounded hillocks called cames are formed at the end of the glacier. We can see here Ice Age isker in remote Quebec, Canada. Isker. Isker, let us look once again what is isker. Isker is sinuously curving narrow deposit of coarse gravel that forms along a meltwater stream channel developing in a tunnel beneath glacier. Iskers. We can see here this picture now. Then came. A depositional feature of glaciation, a small hill or poorly sorted sand and gravel that accumulates in crevasses or in ice cause indentations in the surface. This is about came. Thank you and have a nice day.